Guys, have to see this already we covered, right? HSRP, VRRP. Dinesh, we right? We did the configuration, right? Initially, VRRP, HSRP.
HSRP we did, I think VRRP we haven't done the
Separately, right?
configuration lab, sir.
Okay, so VRRP I'll show you. HSRP you done, right?
Yes, sir. Thank you.
So I will do the VRRP today. Okay. But before VRRP, let me discuss about the multicast. This is a pure theory. So I will discuss the multicast. Let me close this. So this we discuss. Okay. So what is the multicast? First, we have to understand. Let's suppose we have the multiple type of traffic. Means if you are going to do there is a unicast. Unicast is basically going to be your one-to-one communication, right? Broadcast, uh, one-to-many communication, right? Means one, let's suppose I'm a college or Mr. any prime minister like Donald Trump is speaking. So everyone is listening across the globe. That's a broadcast. One is saying and everyone's listening. Means anyone just saying and anyone's listening. Means all are listening. It's not restrictions. But when talk about the multicast, guys, right? Multicast is basically one is saying one to group of people who allow this. Like this class is running. So it's not broadcast, right? No, everyone can access this class. It's happening very close on the Zoom, and I'm the instructor, and you guys are just, a student for my class. So this is like something a multicast. This spelling is wrong. Okay, so multicast, one to group of the people means you're talking, someone is talking, and only the group who really want to join that meeting who can just get that informations. Unicast is one to one, broadcast is one to many, means one to all. Multicast is one to group of people. So in the networking, there are the multicast where some people, let's suppose unicast is happening. So even he want to receive the video, he can receive the video. He want to receive the video, he can receive the video. But in case of he do not want to receive the video, you cannot send the traffic. So unicast can do the restrictions. But in case of the broadcast, what is going to happen? He's sending, he want to receive the video, he can receive that. He want to receive, but he even not want to receive the video, he can receive that. So broadcast is sending to everyone. Unnecessary even not want to receive that, but still you are going to get that all video. Just think about you are going on the road and somebody is honking in front of like you. So you don't want to listen that horn, but still you are listening because he just keep honking due to the some other car. You want to take a side, but still you are getting that all noises. So there is no way like we can avoid because on the road people are just keep honking on the cars sound. So everyone is going to be irritated. Similarly, broadcast somebody is speaking, even somebody not want to receive, but they can receive. But in multicast, in multicast, unicast one to one. But multicast is if the group is going to join the multicast address, that group is only going to receive the traffic. If he is not join the group of the address, he will never going to receive the address. So only the people who join the my group, my class, they only going to leave the class access. Means going to enjoy the class access and can leave at per their schedule. But who do not part of the class, they cannot join my class. That's a very close. So multicast is kind of the group where multiple router switches are going to be joined, and based on them, they are going to be get that all information, whatever the broadcasting is happening, multicast is sending the stream or any communication is happening, they all are going to get that informations. Now, moving next, guys, the next step is if you want to define the multicast having the multiple type of address. So these are the multicast address 224, 232, 233, 239. So always reserve this address, link local address. This is the globally scoped address. You can always use that. And these are also source specific. You want to do the multicast, that you're going to use a multicast. So these are basically used for the multicast. This is for reserved for the link local. This is a globe address. Globe address basically used in the BGP in case of the ISP. So if you just search here, what is the globe multicast address? So it just fed some value in the BGP AS number. So see, globe is the method is basically statically assign the multicast address, this range, allowing the organization with a 16-bit autonomous number in the BGP claim a unique block defined. So basically, it's a method. Globe address is going to be method where it's going to insert some multicast address in your AS number, and that is going to uniquely recognize this is your address. So generally, ISP use that particular address, and you just see globe full form. So there is no full form available, right? So you can just say global local multicast address signed with the process. There's no full form available. So it's just known as a globe address. But the user means original intent is to gloping together a 16-bit AS number in the IPv6 prefix block. So that is going to make your prefix unique. So that is another multicast address. It's just used for the BGP ISP level AS number. There is a limited scope address. So here is the range you should remember, multicast range. Now, when we're going to define the multicast, there is one protocol is going to run. The protocol is known as the IGMP, Internet Group Management Protocol. And this IGMP having the version, IGMP version 1, version 2, and version 3. So if you go here and search difference IGMP V1 versus V2 versus V3. So you're going to get that. So this is quite old, right? This is the message type, means the multicast protocol type, where probably you're going to be build the multicast, but the basic multicast is going to this is like the optimized live ASM multicast. This is a source specific multicast. So right now, most of the time you're going to use IGMP version 2 or version 3. And this is going to work on the query base. All query and flood is going to happen, but this is going to be group specific. This is going to be again general group and the source specific. I'll discuss what is the query, general queries, group specific query, and source specific query. So if you see in this particular slide, if I talk about the IGMP version 1, it will say, hey, I want to join your group if I'm running the IGMP version 1. So definitely, yes, you can join my group, right? But your after 60 seconds, it will ask you, do you still want to join, belong to this group? And if the answer is going to be happen, yes, I want to be still there. So it will there, else it is going to remove. So in that case, of this again for after 60 seconds, you just have to wait. Means IGMP version, it's going to be always wait for 60 seconds. Then after it will keep checking that. But in IGMP version 2, if I joined, then if he want to leave that, so he will say, I want to leave the group. So he can leave that. In that case, your this device IGMP router is going to be ask you, I want to be there or not. So it will wait for timer, but here it want to leave, it can leave that. In IGMP version 3, you can see, I want to join group and include the source. Even here is going to include the source as well. So here you just have a predefined timer. Here we have the join and leave options. And here you can join and leave as well, but you also include your source address as well. That's why if you go here, you can see basic multicast, silently leave, timeout based. This is the method. Means 60 seconds is going to be right out, then you can leave that. So this is the very first thing. You can silently leave from here. After timer is going to be expired. But in the case of this one, IGMP2, explicitly leave group message means your device will send, hey, I want to leave that group. So you are sending the explicit message to the your IGMP router, hey, I want to leave. So they will leave the group. But in case of the version 1, it will leave after 60 seconds if there is no communication is going to happen. Silently, they can leave that. But in third case, it is going to maintain the membership report with the source filtering based on the source which all want to join, and there is no leave or silent leave is going to be there. They are going to be get the report with the source filtering, which source want to join or not. And query type, you can say general, the group is specific, that's a leave and a reply, and that's a source also is going to be there. And you can see here the IGP version 1, original version, hosts silently leave, simply stopping their response period query. Router only stop traffic after membership timeout. After 60 seconds, timeout is going to require. Version 2, leave group is going to introduce, and the all router address will join this 224.0.02. This allow router to immediately send the group specific query to check the remaining members and significantly reducing the leaf latency unnecessary traffic. So this is the IGMP version 2. IGMP version 3 is going to be source filtering, and it's going to include and exclude block or allow traffic based on the source specific multicast group. So generally you're going to use the either multicast 2 version group or this multicast 3. If I go here also in the book, let me see if there is a multicast topic available. Yeah. So these are the quiz. Unicast one to one, broadcast one to all, multicast one to many. This we discussed, right? And go down. These are addresses which I explain right now. This is what I was talking. So IGMP version 2, and they use there is no version 1 even in the book. 3 version, you can see IGP. This is old version, rarely used, right? And there is a IGP version 2 and version 3, which is going to be used, and they are widely used right now. Give 1 second. 1 second, guys. I'm coming back. 1 second. Okay, so now we understand the basic fundamentals, like about the IGMP, how it is going to happen, what is the different versions. So if you read the IGMP version 3, in IGP version 2, when receiver send a membership report to join the multicast group, it does not specify which source would be like to receive the multicast traffic. It will just send the random and I want to join, but didn't never mention the source. But IGMP version 3, it's extension of the IGMP version 2. That's add the support to multicast source filtering, which source I want to join, not only every source. It will give the specific source address, hey, I want to join this particular source. And based on that, your traffic is going to include or exclude. IGMP snooping is basically minimizing the flood, like somebody is trying to do some kind of the snooping activity. So they are going to protect from that particular snooping activity. Now you see, whenever you're going to be initiate the multicast, in that case, what is going to happen? Your one concept is going to check, that is a reverse path forwarding. What is the reverse path forwarding? Reverse path forwarding is check, let's suppose this is my source address. Okay. And I want to send traffic via this way to this one and via this one to this one. So reverse path check is going to happen. Which one is my best path to reply my traffic back to my sender? So they are going to verify based on the routing. And based on the routing, they are going to verify which is my best path to reach the source address where the traffic is coming. So what is the RFC? RPF, sorry, not RF, RPF in multicast. Just read about it. You're going to find some good articles as well. The fundamental security in a situation mechanism that use the multicast router to prevent the routing loop and ensure the multicast traffic flow correctly to the source to receivers. See? So source lookup is going to happen. Means they will verify the routing table and they're going to check what is my source from where my traffic is coming. And based on that, they will verify the routing, which interface I need to send traffic from this one or from this one to this particular sender. In reply packet, this is the RPF check. So it will verify the reverse routing to avoid the any confusion. So they will check the might be traffic is going to receive for this path, but they will reply via this path due to the base routing. They will not do the ECMP. Now in the ICMP, we have the two protocol. One is the PIM dense mode, one is the PIM sparse mode. So what is the PIM dense mode? PIM dense mode is going to be one of the old method. Let's suppose this router is sending the traffic. Okay, this router is sending the traffic. So it is going to receive to this router, this router, this router. Everyone is going to receive. But you don't want to receive this from the multicast. You don't want to receive the R2 as a multicast. So you can prune this IP address. You can prune. So it will send the prune message. Hey, do not send me the any multicast. I don't want to receive the multicast. So it will send the prune message this one as well. If the prune is not going to be there, so if sender is sending, it all is going to receiver. But only this receiver want to receive that. In this topology, this is only receiver. They don't have any receiver to receive the multicast. So this router is going to send the prune message. But in case, let's suppose the one more receiver connected here. So what is going to happen now? He want to receive the message. So he will send the graphed message. So he will say, hey, I want to receive my multicast. Can you just send me? So it will send the graphed message. Based on that graphed message, it is going to reply that. So this is how this traffic is going to reply back to this receiver. But if there is no any kind of the receiver connected here, it is also going to send the prune message. And based on that prune, it will never going to receive any kind of the ICMP packet. Okay, this is the source distribution tree that is known as the PIM dense mode. Now, if we talk about the another, that is a sparse mode, PIM sparse mode. So PIM sparse mode make one of the point as a RP, that's a 𝗲𝗂 point. This is known as a 𝗲𝗂 point. This 𝗲𝗂 point means anyone want to receive any kind of the multicast stream, they will not going to get directly from the sender. They will always join your RP, and RP will further tell how to reach this particular sender. So RP will going to maintain the all tree information of the multicast stream, and based on that, it is going to tell how you can reach to the destination. This is the PIM sparse mode. So they are going to maintain on the RP is the 𝗲𝗂 point, this central point, hub location. So every receiver will send the IGMP star comma G, that is a source specific, and that is going to be your RP. And then RP will further going to give that your sender detail, and then after you can make the membership, because this path RPF is going to be checked. This is the lowest path, this is the highest path. Cost is highest. So it will send that, hey, you just go here and join your multicast. And then it will prune this link. Means because they get the only information of the source based on the RP. And once they join with the best path based on the RPF check, it will remove this link. So this is the RP. So in short, let me summarize, guys. If you want to summarize the multicast, you know what is the multicast? Multicast protocols. That is the IGMP version 1, version 2, and version 3. So you should know what these three versions. Generally, we use the version 2 and version 3. This is the silently going to be join or drop. This is going to explicitly join the leave and join message. This is going to be join and leave definitely, but also include the source informations when you're going to join. Now in this case, they use a PIM mode, and PIM is going to be your dense mode, and PIM is going to be your sparse mode, right? So if I'm going to use the PIM dense mode, right? So PIM dense mode is basically, I have to use that flood and prune. Give me 1 second. Give me 1 second, guys. Once somebody is texting me. Okay, sorry. So I was talking about the PIM dense mode and PIM sparse mode. So this is going to use the flood and prune behavior, right? This is going to use that RP. Means there is a RP is going to be there and everyone is going to join the RP and RP is going to be further give the topology information. And in the dense mode, it's going to be flood and prune. Means everyone is going to receive the traffic. Who don't want to receive, they will prune the message and only receiver will going to give that information. Once you have the source, you'll again send the graph message and it is going to give that. But in that case, dense mode means protocol independent multicast, dense mode and protocol independent multicast source mode. In source mode, source mode, you just have to sparse mode, not source mode. Sparse mode, you have to give that join message to your RP. RP is going to take care of everything, and then after your traffic is going to be allow or disallow. So a little bit you have to learn about the multicast. You just go and learn in the book as well, but just a theory. You don't have to do any practical in this particular course. Okay, so there is some other term as well. If you want to learn about this as well, right? So they are just multicast term. Let me just quickly explain that as well. Even you're going to find that. So SM is like a source-based bidirectional multicast. MSDP is also explained. So source-specific multicast, it is going to use in case of the sparse mode only, right? In the case of the IGP version 3. So they are going to make the range of point. Same thing, what I was discussing. So they are always going to use the source-based multicast. Means they are going to join the range of point and then after they will see how to reach the destination. Bidirectional PIM is basically many-to-many communications. Like unlike the standard PIM, only build the share tree, never switch the source specific tree. This is up and down. But you want to make many-to-many, so it is going to use the PIM bidirectional. When you have the multiple receiver, multiple sender, and you want to send everything to the everyone, then it is going to be huge. They use a multicast discovery protocol. This is one of the protocol that you want to use a sparse mode, then you can use this protocol. They use the mechanism that is a source active, and they use that, RP is going to be there, and you want to make the peer with the RP, and TCP connection is going to build, and RP is going to learn about the local source and the local domain, and based on that, they are going to advertise the all kind of the tree informations. So this protocol, it is going to by default run whenever going to mail the any kind of the uh, sparse mode with the multicast, then it is going to just give some good idea about that how topology going to be look like. So SSM one to many to many, inter-domain source discovery means you have the multiple multicast and you want to talk to them. This MSDP is going to use to just make the communications. RP required, yes. In SSM, not required. This is the PIM dense mode, right? Say tree only. Facilitated STP building means you have to multi-domain, multi-company, multiple group you want to build, and based on that group you want to communicate, then MSDP is going to be used. This is the TCP based message going to there. No IGMP version 1 or 2 or 3, but these are supporting the IGMP version 1 or 2. So this is a short thing you should know about the MSDP as well. Rest is fine. You just know what is RPF, PMS parse mode, IGMP version 2 and version 3. And this is also covered in the your sparse mode. And this is for the this is a dense mode, this is a sparse mode. And this is for the inter-domain communication, you want to do that. Okay, so let me talk now